In this experiment we're going to build a clock generator circuit. In our TTL logic chips TTL logic circuits that we're going to build in a little while, we need to be able to change the state from low to high to low to high and so on without having to move wires or have a switch that we flick. So we want some automatic way of generating a clock signal for our circuit. To do this we're going to use the 555 timer circuit. This is the NE555P, and it's a very versatile little device. It's able to generate very high frequency clock signals, but in our case we need a very low frequency clock signal. We're looking for a signal of about 1 Hertz, which is 1 cycle per second. This means that we'll be able to see the effect that the clock going from low to high to low has on our circuit as it happens, and it means that we'll be able to understand exactly what's going on in the circuits that we're designing. Before we get started, we're going to disconnect the power and we're going to make our circuit a little bit neater. We want to maximize the space that we have on our board because we're going to connect in quite large circuits. So the first thing I'm going to do is I'm going to make sure that all of these rails are connected together across. So this means now we should be able to develop quite a neat circuit because we'll be able to pull inputs from this side or high-low values from this side or from this side to our 555 timer. So that's the circuit as it stands. Now we're going to concentrate on this side of the board, and we're going to try and build it as neatly as we can up onto this side of the board. We're going to put it into the very edge. Just be careful with the legs of the chip to make sure that they go straight into the pins and that you're not bending the pins out of shape. So that's where we get started. You know from working with chips before, the circle indicates that this is pin 1. To choose suitable capacitor and resistor values to get a frequency of 1 Hertz. So I've gone through that in the notes, and it turns out that to do this we need to have a set of components. We need a 10 nanofarad capacitor. We need a 47 microfarad capacitor, and again be careful with this. Note the polarity when you're putting it in. You can see the negative pin has a minus sign on it. And we also need a few resistors. It turns out that we need a 1K resistor for one part of our circuit. That's the minimum value that we can have, and we also need as our design worked out, 14.6K resistor. Now I don't happen to have a 14.6K resistor, but I do have a 4.7K resistor and a 10K resistor, which means that I can get very close to 14.7. So within a reasonable amount, that should do us for a circuit. So we need to wire up our circuit. So if you look at the diagram that we have, I'm going to try and be consistent with the colors that I have. So the first thing I can see with my diagram is that, well, the reset and VCC pins need to be connected to high. So the reset pin is pin 4 and the VCC pin is pin 8. So I need to connect those two pins high. So I'll do that. Now I've got those two pins connected. Again, remember, I have no power connected at the moment, so I'm not going to make a mistake. Also, we need to connect to ground. So the ground is pin 1. So I can connect pin 1 to ground. Well, if we look at our diagram, you can see that pin 5 is our CONT pin. We need to connect that to ground, and this is C2, and C2 is our 10 nanofarad capacitor. So pin 5, which is this pin here, connects the CONT pin to ground. Now it doesn't matter about the polarity with this ceramic capacitor. And then we need, let's look at the next pin. Our trigger and our threshold are connected to capacitor C1, which is connected to ground. So C1 is connected to ground. Just make sure what I'll do is I'll set this up on line 60 here, so it's not touching one of the pins, because we're going to be able to pull 2 wires from it. So connect that to pin 60 and there, so that's connected to ground to pin 60. Again, be very careful that the minus side is connected to ground. And then I'm going to go from this pin, I'm going to connect to pin 6, which is trash. And just try and, it's no harm if you have a few very short segments of wire for this. Pin 6. Okay. Pin 6, just make sure it's in on that side as well. That's pin 6 connected, and we also need to connect to pin 2. We also have to our discharge, the SCH, we need to connect that through R2, and in our case R2 is our 14.6K, so I've done this by I've using 2 resistors. So maybe I'll just change this around a little bit. Just move this pin here. Because this, if you look at your diagram, you'll see that R2 is also connected to the positive side of the 47 microfarad capacitor. So if I pull off this is my 5K, or a 4.7K resistor. Okay, so that's gone in, and I have my 10K resistor, and so that you can see that here that we're going to have this pin is connected, they're connected together, and then from here, so this acts as a 2 resistors in series, which means you sum the value, so 10 plus 4.7K is 14.7K from this pin here, and it means that we're very close to the 14.6K that was required. So that needs to be connected to DSCH. So that's the output there, connected to pin 7. The other thing we have to do is we have to connect the other side of DSCH, has to go high, and we do that with a OR1, and OR1 has the value of 1K. This resistor on the 5-5 timer sets the duty cycle, so our 1K value is the lowest we can have, because we want to have a perfectly symmetrical low-high value, and the closest we can get is 1K, which gives us approximately a 50% duty cycle. The next thing we want to do is connect an LED in to check to see that our clock is working properly, because otherwise we won't be able to tell if there's anything wrong. So what we'll do is we'll connect an LED into pin 3, which is our output pin. So pin 3 is the place where we're going to take our value here to anywhere in our circuit, and we'll connect that to we have to connect that across. So we need a 100 ohm resistor. I might just tidy this up if I get a shorter piece of red wire. So my red wire is going to pin 61, sorry. So I'm just going to shorten that a little bit just to so I don't have to go crossing myself. Okay. So if I connect in a 100 ohm resistor from the output, okay, that goes neatly there, and then we connect in our LED, and just be careful. The longer leg is the positive leg, so we want the positive leg to go between there into that, connect to that resistor, and the other leg to go, the negative leg to go to ground. Okay, so we have a little LED connected. So hopefully now, this is our finished circuit, so hopefully now we can bring that to wherever we need it to go. So hopefully now when we connect it up, we can see our power is over here, so let's connect in the battery. Make sure it's right around, and you can see there's our LED to indicate that the power is on, and then you can see our little LED, and you can see it flashing. It's coming on for about a half a second, so every time it flashes that's roughly 1 second.